We want to solve the initial value problem. The given differential equation is separable. However, we are going to solve it using an integrating factor. If we did want to use separation of variables, we would subtract 2 sine 2xy on both sides of the equation, and then factor out the common factor of 2 sine 2x on the right, which would give us a function of x times a function of y on the right. But again, we'll use an integrating factor, and therefore we need to make sure the differential equation is in the form of y prime plus p of x times y equals f of x, so that we can identify the function p of x. And notice how the given equation is in this form, where p of x is equal to 2 sine 2x. Next, we determine the integrating factor, which is r of x equals e to the power of the integral of p of x dx, which gives us r of x, the integrating factor, is equal to e raised to the power of the integral of 2 sine 2x dx. And now let's work on the integral. This does require u substitution, where u is equal to 2x, du is equal to 2 dx, and therefore dx is equal to 1/2 du. Let's go ahead and write the integral in terms of u. Let's factor out the 2, and then dx is equal to 1/2 du, and u is equal to 2x, giving us sine u. 2 times 1/2 is equal to 1. The integral of sine u with respect to u is equal to negative cosine u plus c. We leave off the plus c when determining the integrating factor. In terms of x, we have e raised to the power of negative cosine 2x. And now we multiply both sides of the original differential equation by the integrating factor. Now the left side of the equation is equal to the derivative of the integrating factor and the dependent variable y. We can write the left side as the derivative with respect to x of, again, the integrating factor times y. And let's write the right side as 2 sine 2x times e to the power of negative cosine 2x. And now we integrate both sides of the equation with respect to x. On the left, integral undoes the derivative, and we're just left with the integrating factor times y. On the right, we need to perform another u substitution, where now u is equal to the exponent of negative cosine 2x, which indicates differential u is equal to negative sine 2x times 2, or just 2 sine 2x dx. This is good news. We now know that 2 sine 2x dx is equal to du, and negative cosine 2x is equal to u. Writing integral in terms of u, we just have the integral of e to the u du, which is equal to e to the u plus c. Which means in terms of x, the antiderivative is e to the power of negative cosine 2x plus c. And now we need to solve this for y. We can do this two ways. We can divide both sides of the equation by e to the power of negative cosine 2x, or multiply by e to the power of positive cosine 2x. Let's go ahead and multiply both sides of the equation by e to the power of positive cosine 2x. And let's show this on the next slide. Remember, when the bases are the same and we're multiplying, we add the exponents. So e to the power of cosine 2x times e to the power of negative cosine 2x is equal to e to the 0, which is 1, giving us 1 times y, or just y on the left. On the right, again, multiplying e to the power of cosine 2x times e to the power of negative cosine 2x gives us 1. And then we have plus c times e to the power of cosine 2x. This is the general solution. To determine the particular solution, we determine the value of c using the initial condition. If y of pi over 2 is equal to 3, we substitute 3 for y and pi over 2 for x. And now we solve for c. Let's go ahead and subtract 1 on both sides, which gives us 2 equals c times e to the power of, this is cosine pi, which is -1, giving us e to the power of -1. We can write this as c divided by e, or leave it in this form, and multiply both sides of the equation by e. Let's go ahead and do that. We'll multiply both sides by e, or e to the first, if that's helpful. This gives us 2e is equal to c times e to the 0, or just c. Now that we know c is equal to 2e, we can determine that particular solution, which is y equals 1 plus c, which is 2e, which I'll write as 2e to the first, times e to the power of cosine 2x. Notice here again we have a common base of e, and we're multiplying, and therefore we can add the exponents. The final form of that particular solution is y equals 1 plus 2 times e to the power of 1 plus cosine 2x, or cosine 2x plus 1. I hope you found this helpful.